So let's take a look at how we go about reading function calls when we're defining our own functions. So here we have a program that has three functions defined. We've got function f of x, g of x, and h of x. And then below that, we have three function calls, but all of them are to the function h. And so the first question is, where do we start looking at this code if we want to understand when it begins executing? So you might ask, well, does the code start executing here on line 5? And the answer is no, not when we're going to take action. When we define our own functions, we have to write the functions before we call them. So where execution actually begins is the first unindented line of code that doesn't begin with def. So that would be here. So until line 20, nothing is happening in the code. No action is taking place. Well, it's not that nothing is happening in the code, but no action is taking place. We're setting up the possibility for function calls, which begin on line 20. Now, I have already noted what is returned here, or what will be printed is 8. So let's walk through how we get that. Okay, so we're going to do h of 3. Now you might have noticed before, we've done some manual walkthroughs of loops, and we've tracked how the variable values change at every repetition of the loop. We're going to do something similar for function calls. So what I like to do is I make a table with a call and a return. And I keep track of all the function calls and what's returned or what the result is. So let's start with h of 3. Okay, so 3 is what's called my actual parameter. And this gets substituted in to x. So while I'm working in h at this moment, x is equal to 3. X is known as the formal parameter. Okay, so let's substitute 3 for x. Does 3 mod 2 equal 1? Yes, 3 is an odd number. Any number mod 2 tells us if it's even or odd. It's even if it equals 0. In this case, it equals 1. So what I'm actually going to return is going to be f of 3 plus 3. I don't know what that equals yet because I don't know what f of 3 is. So now let's take a look at f of 3. Okay, so I'm going to substitute in x equals 3. So x equals 3 minus 1. So that means x is now going to equal 2. And I'm going to return g of x plus 1, which means I'm going to return g of 2 plus 1 because the new value of x is now 2. Okay, so now we go to line 10. And now our x is equal to 2. And I'm returning, so g of 2. G of 2 is going to return 2 times 2, which equals 4. Now I can substitute that value in and start to figure out what is returned by my prior function calls. Okay, so g of 2 is 4 plus 1 equals 5. That's what's returned by f of 3, so that gets substituted in. 5 plus 3 gives me 8. Okay, is that clear? Do we see how that works? If you're unsure, you can always pause the video and go back through and try and see for yourself. Okay, so let's go down and try and see one of the others. Okay. All right, so let me change colors here. Okay, so now I'm going to try h of 4. Okay, now h of 4 is going to get substituted in for x on the h of x. Now the difference is that h of 4 is odd. 4 is even. So now we're actually going to come down to this line. So h of 4 is actually going to return f of 4. Okay, well, I don't know what f of 4 is, so let me just start with the innermost call, right? This is another technique we use. We start, if we have multiple function calls on a line, we start with the innermost one. Similarly, when we evaluate mathematical expressions, right, we have to identify precedence and determine the precedence. And so here, the innermost function calls are typically executed first. So now let's go to f of 4. F of 4 is going to reduce the value of x and return g of 3 plus 1. Well, I don't know what g of 3 is, so let me try and figure that out. Okay, so let's say our x is now equal to 3, which means g of 3 is going to return 3 times 2, which equals 6, which I can then substitute in to g of 3 here, which gives me 7, which I can then substitute in here for f of 4. So now I need to know what f of 7 is. So sometimes it takes multiple runs through this series of function calls to actually determine what the ending value is. So now I need to figure out what f of 7 is. So if I substitute in x equals 7, I'm going to return g of 6 plus 1 because I'm subtracting 1 from x. My x is 7. I don't know what g of 6 is, so I can't perform that calculation yet. But if I say x equals 6 here, that's 6 times 2 equals 12. Okay, and I substitute that in for g of 6, I get 13. And so now I know that h of 4 is going to print 13. Okay, and last but not least, let me change my colors one more time. Okay, now I want to assess h of 5. Okay, so now we've got h of 5. So here I'm going to say x equals 5 now. Our call is h of 5. 5 is odd, so I'm going to return f of 5 plus 5, but I don't know what f of 5 is. So I have to try and run through this. So now we've got x equal to 5. I reduce 1, and then I call g of x. I don't know what g of 4 is, so now I try to figure that out. So now my x equals 4, and you might notice that the variable, every time we call these functions, the parameters change, right? So I have all these x equals, depending on which iteration, which call we're in. So now g of 4 is going to be equal to 4 times 2, which equals 8. I can substitute that in, I get 9. I can substitute that in, and I get 13. Again, oops. Hold on one second. 14. So now